Let's recap what we have learned so far. Consider an electroscope that we saw previously. What had we done? We charged the electroscope using a glass rod that has been rubbed with silk. On doing this, the gold leaves at the bottom diverged, showing that they have acquired a charge. If we now connect the metal knob at the top with a piece of metal wire to the ground, we see that the gold leaf collapses. If you had tried the same thing but instead of metal wire used a silk or cotton thread, nothing would have happened. The gold leaves would stay charged and diverged. Why is this? This experiment highlights the difference between conductors and insulators. Conductors have large amounts of free charges in them. These charges can move from atom to atom freely inside the bulk of the metal. You can imagine a solid conductor, like most metals, as a collection of fixed nuclei submerged in the so-called electron sea. So, electrons are mobile and can move inside the bulk of a conductor or through different connected conductors. In comparison, most of the electrons in insulators are bound to parent nuclei. Thus, at any given time, under standard conditions, insulators don't really have any free charge. So, conductors are characterized by free charges, electrons that are so loosely bound to their parent atoms that they can skip from one atom to the next. While insulators are characterized by bound charges for the most part. Insulators have only a very tiny fraction of charge inside them in mobile form. When we rub different insulators together or rub a conductor with an insulator, it is these very small number of free charges that move from one material to another, creating a small imbalance of charge. So, to reinforce what we have learned so far, conductors allow bulk flow of charges. Insulators don't. Both contain plenty of charge, but only mobile charges can support conduction. Coming back to the experiment. When the metal knob is connected to the ground with a metal wire, the wire is able to provide a path for the excess charge on the electroscope to flow to the ground. This is why the gold leaf collapses. But make no mistakes. All materials, whether the gold in the leaves or the metal in the knob or the glass rod or silk thread, can be charged, or more accurately, you can achieve a small imbalance of charge in all of them. Doing this with silk does not work because silk, being an insulator, cannot support large flows of charge. It simply does not have enough free or mobile charges inside it to be a conductor. The reason for this is that the earth can act as an infinite source or sink of charge. We will not get into the why of this yet, but for the purpose of this lesson, you can safely assume that the earth can supply or absorb an infinite amount of charge. Since in solid conductors, the mobile charge carriers are electrons, we can say that earth can supply or absorb an infinite amount of electrons. To understand this phenomenon needs you to first get acquainted with the concept of electrical potential, which we will learn in coming lessons. Let us summarize what we have covered so far.
Manorama Horizon, learning made simple.